Lesson 3, primitive functions 4. So we have the function y equals 2x plus 1 to the power 3, and we're going to differentiate that function. Differentiate, not integrate. So now we'll have dy dx, according to the function rule, 3 comes down, and we'll have 2x plus 1, and reduce that 1 by 1 to get 2, and look inside the brackets and multiply by 2. Now instead of tidying that up, I'm just going to take that 2 at the front and write this 2 times 3, and then have 2x plus 1 all squared. Now you'll agree that if I then integrate that function, I should get back to the original one. So I'm going to do that. I'll say the integral of 2 times 3 outside of 2x plus 1 all squared dx must be equal to 2x plus 1 cubed. Now 2 times 3 is a constant, so I'll take that 2 times 3 at the front. Okay, sometimes called the special rule. Okay, and then we take this, and we get this result here. I haven't added the c at the moment. I'll do that at the end. Right, now I can divide, this is like an equation, I can divide both sides of the equation by 2 times 3, and I get the result, the integral of 2x plus 1 all squared dx must be equal to 2x plus 1 to the power 3 divided by 2 times 3 plus some constant. Now note here you've got this 3, and that's that 3 there. So the power comes down as before, but we multiply it by the coefficient in front of the x. So now we're ready to write out the rule and then apply it to some examples. So here's the rule. If I have the integral of ax plus b to the power some power n dx, then the result will be ax plus b to the n plus 1 over a times n plus 1 plus some constant. Now this is sometimes known as the special rule. Okay. And it's a very, very good rule to remember. Very important rule to remember. And we'll have a look now at a few examples. Alright, well, you might like to have a go at this yourself. So just pause the video and just apply the rules. It's actually quite simple. Okay. Alright, so what you should have done is just written down 3x plus 1, increase it by this by 1 to the 5, over 3 times 5. Pretty simple, isn't it? Plus some constant. And of course then tidy up and write that as 1/15 outside of 3x plus 1 to the 5, or put it all over 15 if you like. Okay? Okay, now how about this one? Looks a bit daunting at first. You can certainly see the use of this rule with this one. Okay, this one here, you rewrite as 2x plus 1 to the half. Now I'm sure you can do that. Okay, did you get this? 2x plus 1. Now add 1 to this, making it 3 on 2. Whoops, 3 on 2. Over 2 times 3 on 2 plus the constant, and of course this all cancels out. You just get a 3, so it becomes 2x plus 1 to the 3 on 2 all over 3 plus your constant. Okay, and finally this one. Yes, you have to write that again in the index form. That's equal to the integral of 1 minus 2x to the negative 2 dx. Applying the rule, that will be 1 minus 2x. Careful with the signs. Add 1 to that, becomes minus 1 all over. This time it's minus 2 times the minus 1 plus the constant, and of course that becomes the 1 over 2 outside of 1 minus 2x. And that completes those few examples.